Hi, my name is Dave and welcome to my Solidity Basic series. Here I will guide you through the fundamentals that you need to become a blockchain developer. At the end of this series, you will be able to understand how Solidity works and you will be ready to move on and learn more advanced topics to code smart contracts. So you can find all the videos on Skillshare and I left a link in the description. Please like and subscribe so more people can find those videos and start their blockchain development journey. Hello everyone and welcome to this next lesson of Solidity Next Steps. So in the previous lesson we covered inheritance, which is the function, well it's not a function, but it's the capability of a contract to inherit and be able to use functions and variables from previous contracts. And today is going to be a slightly shorter lesson, but I want to cover something that is part of inheritance, that is the linearization. So when you have multiple contracts all inheriting functions and variables from previous contracts, you will have to state them in a specific order. And we're going to cover what this order is. I wanted to make a specific lesson about it because I think it can be pretty confusing. So we're going to build from the previous contract that we already wrote, the inheritance one from the last lesson. We're just going to add a couple things and we're just going to go a little bit deeper into the inheritance thing. So the last time we ended up with these three contracts, right? The third contract that we made, we just left it empty because it was already getting all the functions and everything from the previous contracts. Now I want to show what the linearization means. So let's just make a modification to this second contract. We're going to add another function here that we can call letters. Let's add a function that we call letters. And this function is going to be pretty similar to all the previous one. It's just going to return a string. So it's going to be public, pure, and we can call it the returns, because it's going to return a string in this case. Oops. And then it's simply going to return a string saying I am only in the second contract. And yes, so now we have these extra functions. So I made it this way because I wanted to have a function that was only available in this second contract. Now what we can do with this third contract, let's say that we want to have actually I forgot here, this one here wants to be virtual as well, so we can modify it in the second contract. Now let's say that we want to have access to both the second contract and the first contract. I know that is not like useful or practical in this example. It doesn't do anything. We could access it, we could already access it right away, but I want to demonstrate the linearization. So let's say that from this third contract we want to inherit functions from both first and second contract. Let's say that the second contract here doesn't inherit it anymore. We will have to modify a whole bunch of stuff, but for now let's just leave it like that. So how can we make this third contract inherit everything from the first and the second one? We will have to we already inherit from the second contract here. The third contract is second contract, but I can't just add the first contract here in a random order, because otherwise the compiler is gonna give an error. If I now try to compile it, it's gonna give an error here. And well, this error is not the error that I expected. I missed some. forgot the semicolon, obviously. But yeah, now we get the actual error. And here it says linearization of inheritance. Inheritance graph is impossible. And that's because this is because of how Solidity looks at the inheritance of contracts. So what the documentation says is that the linearization is from the most base-like to the most derived. So this means that when we list them, we have to list the contracts in an order that goes from the most base-like to the most derived. So if we go look at this, at our picture here about inheritance, and we have the graph that shows the base contracts, and this is pretty much the structure that we have now, where we have the first contract, and then the second contract inherit from the first contract, and the third contract we want to make it in a way that inherits from both. So if we look at this one as the first one, second, and third one, we have to list these two in the inheritance. So which one is the most base-like? The most base-like is the one that inherits the less. So in our case, the most base-like is going to be the contract number 1, and the most derived is going to be number 2. So we're gonna have to list them in this order: first contract and then second contract. So if we go look in here, we will just have to invert them, invert the two of them. And we'll put first contract and then the second contract. Now if we compile it, it should work. And the contract works, but there is something else. Because I forgot to put memory here. Remember that every time that you string somewhere, you have to put the memory. Now Control S to compile it. What did it go wrong this time? Well, there's a whole bunch of stuff. What did I mess up here? Oh, I think it's just because we didn't put the functions in yet. So we have to place the functions in there to make it work. So let's go take the actual functions that we want to pass and override. So we'll take number 1 and number 2 that are in both contracts that we want to inherit. And let's fix this. So now, because we're inheriting from 2 different contracts in here, we are going to have to add an extra information where we have override, because the idea is that we want to replace these functions, right? So the 150 and 200, we want to replace it with, I don't know, 500 and 600, just like we did with that one. But because we're inheriting from 2 different contracts, we're going to have to specify which contracts we are getting. So after the override, then we're going to have to specify first contract and second contract. In this case, the order in this one here doesn't matter. It's just a way to say, hey, you are inheriting these functions from these contracts. And that's how Solidity wants it. And now if we compile it, now it works. Sorry about that, I forgot that step. So this is what I wanted to show about the linearization. Okay, now that we compiled it, if we want, we can test it out just to make sure that it does what we meant. But since it compiled correctly, it should. There isn't really any specific logic in here. So we're gonna go and compile the third contract on our virtual machine. We'll deploy, and you can see we have everything available. We can access the original first function. We can access this letter function that is all in the second contract. And if we call number 1 and number 2, those are going to be the overridden. The number 1, number 2 is going to be the overridden ones. And the number 3 is going to be that first one only in the first contract. So this was a little bit shorter video about the linearization and the inheritances. It's just I wanted to make sure that I will go step by step and not make it too extra complicated, because it can be pretty confusing, especially when you start getting many different contracts that talk together. And that's what we're gonna see in the next video. So in the next video, It's going to be pretty cool, actually. We're going to explore the ERC20 standard, and we're gonna be making our own ERC20 token, and we're gonna deploy it on an actual blockchain. Obviously, it's gonna be the testnet, so there is no real gas fees involved. But I'll show you how we can make our own token, and then deploy it on a testnet. We can deploy it in the Ethereum testnet or in the Binance Smart Chain testnet, and we like everything from here. From Remix. So I'll see you in the next video.